Hi everyone. Nice that you found your way here to this talk today, and I'm glad you want to talk with me about paranoia, basically. Yeah, my name is Erik Sommer. I work in the platform squad of Grafana Labs, and part of my job there is to run basically the backup for our observability. Because as you can imagine, we built observability, so you maybe guessed we use it ourselves, would make sense. Let's see if that is the case. So today we will see how we use our own tools for testing and observability at the same time. And much more important, what we do to be safe doing this. Because if you're constantly testing on the things that you observe your stack with, that sounds like a very bad idea. And the last one is the last bullet point of this presentation. Let's try something else today. We try to paint a picture how you, if you want to do such paranoia, can do it yourself maybe. How would we start? Most of at least newer build stuff these days will be on Kubernetes. Most of our workloads are also on Kubernetes. So let's start with a small single Kubernetes cluster somewhere in the world. You will have some workloads running there. You have the normal tools that you get with Kubernetes. You have your kube control, maybe even some more advanced tooling like K9s or something like that. So you have some sort of visibility. You have basically this. A command line tool that gives you some prompt. You can look at some namespaces. You can see what CPU is used, what other values are maybe interesting, so you don't fly blind. But it's just snapshots. You don't have an overview over your cluster, or you have no time series, so you can see progression or anything like that. We basically need a component to gather time series for us, which we all do nowadays probably. So the very simple thing to do is put a Prometheus there. In every cluster, we deploy a Prometheus. From now on, every orange arrow will be scraping or writing metrics to some external system. We have time series now, which is good. We are not bound to see just a snapshot that we currently have. We also can query our metrics with PromQL now. The UI of Prometheus is, up to last week, it felt like the 2000s. Last week they released Prometheus 3.0 with a completely overhauled UI. Now it feels like 2020. It is still, you can type some PromQL, you can see a graph, it's good information. You have information about your status of the scrape targets. You can even configure some alerts. Still, you have to know PromQL. You have one graph at a time. It's not perfect. So a dashboard would be nice, wouldn't it? You can maybe guess what's happened next. Yeah. Deploy Grafana alongside. Every purple arrow from now on will be querying metrics in some way or form. We have this now. We have a nice dashboard. It has several advantages. You don't have to type the same query over and over again. You can even give the dashboards to not so advanced users that are not familiar with PromQL, and they can derive their own observability for themselves. You can even query other data sources like PromQL. Just connect whatever business system you have running alongside and get your business metrics at the same place. All nice and well. So we are done, right? That was a short talk. No. At some point, if you are a company that operates globally and have customers globally, at some point you go globally. So we add other clusters. The reasons can be for various reasons, mostly local laws. So some of us operate in Germany, so you guess most companies have to have their data in Germany. So when we provide clusters in the Americas, they don't like that, so we need something locally. Also, if you want an application with a decent latency, it's also not a bad idea to deploy it near to your customers. You end up with a lot of clusters. Hundreds, maybe some companies thousands. I don't quite understand why, but this is another discussion. You still have per cluster observability. So if I want to know the state of my Europe cluster, I have to go to the Grafana there, look at the metrics for the Europe thingy, and so on and so on. The disadvantage of this is quite clear. We need the global picture. When I have just the metric of every cluster contained in that cluster, I can't answer questions like, what is the overall count of all users for this application all over the world? Just sum it up. It's not possible. It's scattered around different Prometheus and different Grafanas. Let's introduce the global picture. Grafana also has solutions for that. You can use other vendors. That is purely neutral. You need some sort of centralized metric store, in this case Mimir, and you need an agent that writes to this metric store. And of course, when you have a global local store, you need also a global Grafana that can look at that. We call this, inside of our operations, the operations cluster. It's a Kubernetes cluster that is just there for one customer, and that are we ourselves. This has some advantages. We can test releases there before we go to production. The good thing is, we can test it on real data. We can test it on the data of the customer Grafana labs. The bad thing is, we can also break the customer of Grafana labs. We can also do real load testing when we have real data. But as we start to see, when we test on ourselves, we should have some sort of backup system in place. So we still leave the local Prometheus and Grafanas in every cluster in place, just as a backup. You also need centralized configuration management at this point, because your local Prometheus, your local agent have to be in sync with the scrape config, and also the ruler for Prometheus and Mimir have to be in sync as well. We use JSON for this. If you want to know about that, find me in the break. It's always good for a great discussion. It's time for alerts. Every gray arrow from now on are some alerts rooted somewhere. Let's add an Alertmanager. We use vendor global Alertmanager from Prometheus for this, and it is based also on our operations cluster. The centralized Mimir and the decentralized Prometheus all send their alerts there, and it gets deduplicated there. So if a bad state of an application is happening, in theory, the local alert should fire, and the global alert should fire, and the Alertmanager deduplicates this, and for the time being, just writes this to Slack. But there's more than metrics, aren't there? There are several signals, and we also want this for our internal developers as well. So we deploy alongside Mimir as well Loki and Tempo for logs and traces. You can also produce alerts from Loki, that is totally possible. And you can argue you have a backup for logs in a sense. You still can go to kube control and look at the local logs from the cluster. That is possible, but we saw the disadvantages. We do not deploy another backup method for Tempo or Loki. That would be not very practical. Last step, I think some of us will be on call, we all love it. So just sending alerts to a Slack channel just don't cut it. So also deploy an on-call application in your cluster so that you can wake up your engineers. That's always lovely. So at this point, we're done. We have a centralized solution. We have a lot of backup in place for our engineers. So that's all well done. Sorry, I'm still 15 minutes short of my talk, so it can't end here. And also, we did not go yet to the paranoia part. Let's go there. And start with some what-if questions. What if Alloy fails and we don't have scrapes anymore in our global Mimir? We would not know that because is Mimir broken? Is Alloy broken? We need an instance that can decide, okay, your scraping components are down. We introduce for this something that we call the meta instance. For one reason, it's always good to call something meta. And this is a good way out if you don't know how to name something. No, jokes aside. We call it meta instance because it is a Prometheus that is monitoring all other Prometheus and scraping agents for that matter. So if something is wrong with the scraping components of our clusters, this meta instance will let us know and is also able to send alerts to the Alertmanager and on-call for that matter. So we can then let the teams know that handle the Alloy, or they get alerted as well for that, that they have to fix it and can get our global observability back in place. More security, fine. What if whole clusters go dark? When you work with cloud service providers, it is always possible that local zones or even whole regions go dark. That can also happen to our operations cluster. So in theory, all that right side that is hosting on-call, Alertmanager, the meta instance, can disappear. That's not good. We introduce for this second set of meta instances in the Alertmanagers that check each other and also scrape all other scraping agents. The Alertmanager, it's called gossip on each other. So if an alert arrives at both of them, only the primary instance will send this to on-call. And we deploy these clusters. The second one is typically just one of our other production clusters at the other side of the globe. So even the case that someone all cuts the nice cables that run via the Atlantic and you end up with a split brain, in theory, both parts of the split brain still can be observed, at least with basic components. But what if your backup struggles? It's story time. We had this set up until 2023, around the time. Every Prometheus and every cluster still scrape all workloads of these clusters. And some of these clusters got big, very big. When your CSP asks you if you please can't do this, what you do with Kubernetes in the moment, you know that you should change things. To loosely quote a Prometheus maintainer, Prometheus can handle up to 30 million series. That's already not recommended, but that is there. Let's draw the limit there. Let's find the error. Well, we were constantly at 75 million series for this Prometheus. They run, they operated, restarts were painful, cardinality explosions were something else. So at some point we had to fold and realize if you can't find a machine big enough at a cloud provider anymore to run a Prometheus, you should probably not do it. But at this point, we also had a cultural problem. We started out with this local Prometheus in every clusters. all engineers worked at Grafana were used. It is there. You can go there, look at the data. And at the same time, we improved our own solutions. At first, they were quite buggy, were down sometimes, so the trust is not necessarily there. So people were not used to the backup as a backup, they were used to the backup as a primary place to go. In the end, we had to forcefully tell them, yeah, it's done now, you don't have that anymore, please use the centralized solution. We still kept the Prometheus in place. Some things you don't want to do with intercontinental latency and all that. We scale a lot of our components by metrics. You can do that with Kedar and some Prometheus compatible interface. And you don't want to do that on a global scale. You want to have metrics in your cluster by scaling that. Also, if you scale in Mimir with metrics from Mimir, and no, don't do it. That is a disaster bound to happen. So we simply changed the backup Prometheus to something that we call nowadays a critical Prometheus. It just hosts all the metrics that are necessary for the critical operations of that specific cluster. It's not a very typical use case for Prometheus. Normally you say, scrape everything, discard some things, and we do it quite the other way around. We just opt in for very specific metrics, for very specific namespaces. It's a long regex, I say so much. But this works very well. It's still very chunky Prometheus, some million series, but even our biggest cluster, we can keep it in check, and it works well. Coming to the final paranoid part. What if just everything goes wrong? We have a lot of redundancy at this place. But still, you see, on-call is there, lonely, because it's just not practical to run a second instance of that and get out 2 phone calls to your on-call engineers. That's annoying. So what if anything in that chain happens? Or for that matter, all of it disappears. It's always DNS, right? So you need something outside. We use for this deadman snitch. It's not something we deploy. It's a service that is offered, and it is somewhere. And it does exactly that, what it's promised with its name. It's a deadman snitch. So we have a ping that originates from the meta instance of the operations cluster. This ping is an alert that fires constantly, every minute. It goes through the Alertmanager, through the on-call alerting system. It gets routed through all of that and arrives at deadman snitch. And as long as deadman snitch hears that signal every 5 minutes, it's fine. When this stops, I think after 20 minutes, a phone call will get out to, at this point, 5 dedicated engineers over the world. And it's basically the sign for us, you have a bad day, a really bad day. You don't know yet why, but all of your observability is down. At least you know that. It fired so far 3 times. 2 times of that were false alarms, because at the end you also test the deadman snitch system yourself. But at one time, yeah, on-call deployed a bad version. No alerts were getting out at all anymore. And also the on-call people were not alerted anymore. And we had to tell them, no guys, please do something. They still had metrics. They could look in the observability. It was all good and resolved after some minutes, but the external system worked. So what did we learn today? Backups can be complex. They can get out of hand quickly. They can even blast to sizing limitations. And the balance between safety, cost, and even complexity is a difficult one. You don't have to do this. Partially, I would not even recommend it, but I would argue we as Grafana Labs have to do it to keep our products safe and only deploy versions that are good for production. And yeah, with that, I thank for attention and open for questions.
Thank you very much, Erik. We have some time left for questions, so please raise your hand if you have any questions for Erik. All right. So how many people do work on this setup?
2?
2 persons?
And to be more specific,
Building and maintaining this?
The interesting thing is the teams that develop Mimir, Tempo, and Loki run these components themselves. That is the idea of the whole thing. They have a very big system that they can test on. On the backup system that keeps all that in place and makes sure they can do that, that is basically 1 to 2 persons that maintains that. And it's also mostly my side hustle. I do other stuff.
How does this work out with only two persons doing all this?
Prometheus is a very stable thing. Let's see, we deploy 3.0 next week probably. I will get back to you about that. But it is very stable. I would even argue most engineers that work for our products don't realize that this is even there. Because it looks very obfuscated, and even if you are deep in observability, it can be very overwhelming. But they just know, okay, there's an Alertmanager, it sends out alerts, and sometimes I don't find this alert in Mimir, I find this alert somewhere else. And they don't know how this gets duplicated and is backupped, but they realize, okay, there are measures in place that we can deploy our versions safely.
Awesome. Do customers get to see any of these data?
No. No. Not quite. We had a customer that came to us and asked, how do you do CADA with Mimir? And we were quite transparent and said, not. That's not really recommended for latency and even poor query load. And we helped them to actually implement this critical Prometheus situation themselves. Because at the end, if your tool is not built for such use cases, tell them and let them know, and they were quite happy with that. But they don't do all the other stuff as well. Because for that, they used us, and yeah. So that you are in the position to just use the normal stack that we offer, you don't need the backup measurements.
Awesome. Thank you very much, Erik, for giving us these insights. We have one more question over here. Here we go. I just need to enable it. Just one sec. Let's go.
Yeah, thank you, Erik, for the awesome presentation and good job. And by the way, I use Prometheus as well. One question, on a light note, how did you bring out the paranoid aspect? Because I think it's something, I liked that heading. But on a more serious note, are there opportunities around AI from a alert management perspective? What do you think about that?
I would consider myself more in the skeptical camp of the AI hype. We use AI in our products, so we have something that is called SIFT. Don't ask me what it stands for. I'm pretty sure it's a very clever acronym, but I forgot. And it's basically it looks through all the telemetry systems that you have there, logs, traces, metrics. There's also profiles nowadays, but I had to cut the place somewhere. And when you have an incident, you just can tell it, cluster there, namespace there, go. And it comes back with, I found this weird thing, and this weird thing, and this weird thing. In the logs, there are so many criticals. Is this maybe related? And it's normally what you do in an incident when you see, oh, it's bad. Let's look through some ideas, and it does that for you and present you some ideas. You're still in the position to make your own conclusions and decide what is a red herring or what is not. But the process of bringing up ideas, that's very good, doable with an AI. And I like that. But I'm very skeptical about the AI can draw the conclusion for you part. Because AI will also hallucinate a conclusion for you. And you don't want to have that in an incident. But presenting ideas, sure, why not? So you're getting warm now.
You have to stay awake.
Are we insured? Okay.
We are.
So
Maybe.
I can talk here. Thanks for the great talk. Just wondering, obviously you're running observability on your Grafana stack also.
Yeah.
I'm curious if you ever considered also some kind of external stack for diversification purpose, like extra tools which brings outside. It's also running because when Grafana fails, you also fail your cluster.
Yeah, in some sort of way, Prometheus is this external stack because Prometheus is not owned by Grafana. If you dig deep, you maybe find that some portion of the maintainers are employed by us, maybe a big portion, but it is not owned by us. So it is an external software, and we just run the plain releases. You could argue, yeah, you can also use another cloud-based vendor solution to look at this from an external perspective. I don't want to pay that. I'm pretty sure my CTO doesn't want to do that as well, because we already do our own stuff and we use it pretty extensible, and it is a sizable chunk of our operations cost. And to put on top of that another vendor is also a marketing nightmare to happen, probably. So no, we don't do that, but we use Prometheus. It's not our own, and it is our backup.
Yeah, that makes sense. Thank you.
Oh my God. It comes
You
back.
you can keep it and maybe throw it to the next person.
Oh, yeah, we make a game out of it.
Do we have any more questions? Last chance, at least for now. If you figure out you want to know something, Erik will be around, I guess.
Sure.
You can catch him on the hallway or during lunch or whenever. Again, thank you very much for being here, for providing these insights. Erik Sommer.